Hello everyone. In today's experiment, we are dealing with the design and implementation of low pass FIR filter and also the design and implementation of high pass FIR filter. Before we get into actual experiment, let's see what you mean by this low pass filter. A low pass filter is a filter that allows signals with a frequency lower than a certain cutoff frequency to pass through while attenuating signals with frequencies higher than that cutoff. These low pass filters are used in a variety of applications like in audio processing in order to remove high frequency noise, in signal processing to reduce the high frequency fluctuations in data, and also in communication systems in order to limit the bandwidth of transmitted signals to reduce interference. Now, let's see what you mean by this FIR. FIR states that it is a finite impulse response filter. It is nothing but it's a type of digital filter which is widely used in signal processing. It is called finite because the filter's response is of finite duration. That means it settles to zero after a certain number of input samples. When we comes to the characteristics of FIR filter, it is called linear phase response because it preserves the shape of signals by not reducing any phase distortion, which is very crucial in applications like audio and image processing. And it also has got a name, finite impulse response. That is because the filter output depends only on a finite number of previous input samples. Once the input signal stops, the filter response settles to zero after a finite number of steps. These FIR filters are inherently stable because they do not have feedback loops. The output is determined only by the current and previous input values. Now, when we come to the types of FIR filters, we are having basically four different types of FIR filter. One is a low pass FIR filter. As I told earlier, it passes only the low frequencies and attenuates high frequency. The next one is the high pass FIR filter, where it passes high frequencies and attenuates low frequencies. Then we have a band pass FIR filter, which passes a specific range of frequencies, and also we have a band stop FIR filter that attenuates a specific range of frequencies. Now, today we are designing this FIR filter. There are different techniques we can use in order to design the FIR filter. There are techniques like windowing method, frequency sampling method, like that. But we are doing an experiment, or we are designing an FIR filter using a windowing method. There are different kinds of windows like Hamming, Hanning, rectangular, triangle, like that, which is basically used to truncate the ideal infinite impulse response. Okay, we use this technique to design a FIR filter. Okay, before we get into the program, let's see what is the design specifications we need in order to implement the FIR filter. Okay, to implement the FIR filter, these are some of the parameters which is required. The first one is the cutoff frequency. Cutoff frequency is nothing but it is a frequency below which the signal will pass and above which it will be attenuated. Okay, and second one is the sampling frequency. So it is the rate at which the input signal is sampled. Third one is the filter order. This is related to how sharp the cutoff will be. Okay, and the last one is the window function. That means what type of window we are using in order to control the filter's transition band. Next, these are some of the parameters we require in order to design a FIR filter, and let's see the syntax of it. This is the syntax in Scilab to implement FIR filter. This WFIR, that indicates it is a FIR filter, and the arguments within this is the first argument F type, that indicates a type of filter you are using, whether you are using a low pass filter, high pass filter, band pass, and stop band. This is what the letters you should use for that one. For if you are using a low pass FIR filter, then you have to write it LP. If you are using a high pass FIR filter, you should use HP. If it is a band pass, BP, and if it is a stop band, it is SB. This is out of these four, you need to specify one in the first argument. And the second one is the order. As I told, it is given in the design specification. Okay, the order of the filter, and C is the cutoff frequency, and W type indicates it is a what kind of window we are using, whether we are using a Hamming window, Hanning window, rectangular, triangle. These are some of the names different for different windowing techniques. And the last parameter that is used when we are using only the Kaiser window, right now we are not using that one, we make that parameter as 0 0. Okay, and these input values gives the output, three outputs. One is a H is nothing but it is an impulse response. Second one is the H omega, that is a magnitude of frequency response. And third one is a omega, that is a frequency in radians. Okay, now let's see the problem statement to design an FIR filter. This is the problem statement I have taken, where we want to design a 35 order low pass FIR filter using Hamming window with a cutoff frequency of 2000 and a sampling frequency Fs is equal to 8000. Let's see now how we write the program in order to meet this design specifications. Okay, for that, as you are already familiar with Scilab, this is what the program is. This is the basics, CLC, clear and close, and this is the order. That is what we have mentioned. In order to design, we need four parameters. One is a order, second one is a cutoff frequency, third one is a sampling frequency. Okay, so we have defined all the three parameters, and whenever we are using a cutoff frequency in Scilab, in FIR, in designing an FIR filter, we have to use a normalized cutoff frequency. Normalized cutoff frequency is nothing but it is a division of cutoff frequency by sampling frequency. That is the normalized frequency. We should use that one in the design of FIR filter. Okay, as I told earlier, this is the syntax. Okay, where WFIR indicates it is an FIR filter, and LP indicates it is a low pass filter, and N is nothing but it is an order of the filter. Here it is 35, and WC is the normalized cutoff frequency, that which is equal to FC divided by Fs, and HM indicates we are using a Hamming window. And this parameter we basically use for Kaiser window. Since we are not using that one, we are given a value of 0 0. Okay, and next we are displaying this one, impulse response filter coefficients. It will display all the filter coefficients values. Okay, and this is the figure, and we are plotting the figure H omega versus omega. That is a magnitude of frequency response versus omega. Whenever if you are written like this, only omega, the value will be displayed in radians, but I want to see the result in hertz, the frequency values in hertz. That's why I multiplied with Fs, multiplied with sampling frequency. That will give the x-axis value in hertz. Okay, and this is the title given for that one, that is a magnitude of frequency response, and this is the x label, that is a omega, which will be in hertz, and H omega is the magnitude of frequency response. Okay, this is the program. Now let's run and see how the output will be. See, this is what the output you got. It is a low pass filter. It is passing up to some cutoff frequency. After that it is attenuated. Okay, and here also you can see the filter coefficients in the these are all the filter coefficients which is displayed. Okay, fine. That's, you can try with in a similar fashion, you can try with different kinds of window, like by changing HM into Hamming window, or you can do it for triangular window, you can do it for rectangular window, like that. For different kinds of window you can try out in the lab. Okay, now let's see the same thing for a this program. What we done, it is for a low pass FIR filter. If you want to do it for a high pass FIR filter, means you just have to change this LP to HP. Okay, that will, let's see how the output will be right now. See, till some cutoff frequency it is attenuated. After that cutoff frequency it is passing the signal. Okay, this is what the difference you can see for the low pass and high pass filter. Fine. Here also, for this one also, you can change the window technique, and you can try out for different window techniques, and also you can change the different change the order of the system, and also the cutoff frequency and sampling frequency. You change these three values, and also the window method. Then you can try out for all the possibilities of FIR filter. Okay. Thank you.